We're having a panel discussion. We're really excited to have several companies represented to talk about the use of composites, advanced materials in sporting goods. So this should be a really not only informative but very fun discussion, because we get to see some of the sides of things that we don't normally see. So I'm going to turn it over to the panel moderator, Dustin, who's going to introduce and lead us through this discussion. So thanks, everyone. And thank you, Dustin.
Absolutely, and thank you for having us. Today's presentation is titled Lighter, Faster, Stronger, Outdoor Product Development Using Advanced Materials. We're going to go over a selection of different products that can be made using carbon fiber and hear from some of the companies that are actively working on them. And so as we get started, we'll do a round robin of introductions. And if I'm able to share my screen.
Should be able to. Yes, yeah, we can see your screen, Dustin.
Excellent. So just kick off. I'm the moderator for today. My name is Dustin Cederholm. I'm the marketing director for UAMMI, which is the Utah Advanced Materials and Manufacturing Initiative. We are a state and federal organization, mostly run for the state of Utah, but we do participate in federal activities. I'll explain a little bit more during my section. But what we do is bring together the manufacturing and advanced materials industry within our state. And in addition to that, I am the former executive director for the Utah Outdoor Association. I'm a SOBAM member, which is the State Outdoor Business Alliance Network, which is made up of a number of organizations similar to ours throughout the nation, and I sit on the National Small Business Leadership Council. And so I'm very excited to talk with you guys, but more excited to bring you the team that we've compiled with the panel, and I will pass it over to you, Matt.
Okay, hello everybody. Thanks for welcoming. I will try to share my screen also, maybe.
Oh, if you just want to introduce yourself.
Okay. Let's do it. So yeah, I'm Matt from originally from France. I am now based in Mexico, leading mainly the development of Epsilon Composites, a French company here in Northern America. I have also additional activities for consulting around the composite industry. But yeah, today the idea is to present mainly what can we do through protrusion and for sporting goods.
Fantastic, Carl.
Yes, my name is Carl Turner. I'm a design engineer for NV Composites. I've been here for since the start of the company, so we're about 15, 16 years old. We primarily make bicycle products for the high-end consumer, ones that spend more money that probably all of us make currently. But yeah, I'm mainly I'm on the design and development and research side of things, and yeah, we really enjoy the industry we're in, and we're passionate about it. And I hope I'm able to express that and get you guys all excited about the different products that we make. So awesome. Yeah, thanks.
Very excited to have you, Carl. And Stu.
Hey, good morning. First, thank you so much for having me here. It's a pleasure to be a part of this. I am, as the slide says, a product development engineer at Black Diamond. I am more or less the project manager for all of the Jet Force airbag products and avalanche transceivers. My discussion will be about a carbon ice axe, but my background is 15 years in the composites industry, working at Namo Composite Solutions and Rock West, and putting an emphasis more on the aerospace and defense components before I had an opportunity to come to Black Diamond. So again, thank you for having me here, and I look forward to these discussions.
Thank you all very much. So just before I turn it over to these guys to talk about the what they do. You've heard a little bit about me, so we can skip this, but I want to set up kind of the industry, who we are. So before I jump into it, I do want to tell you a little bit about UAMMI and how we put this together. UAMMI brings together public, private, community, industry, and education partners to assure growth. And that is how we've reached out to some of our network and partners to put this panel together. One of the things that I think is interesting for the listeners today is some of the economic studies and resources. And so you can see this QR code to the right. I suggest that you look at that, as we are working on some recycling projects, as well as writing some reshoring economic studies, reshoring reports, excuse me. But all of those are accessible there. And I think, as I've heard some of the other conversations going on today, I wanted to include this and give this to you guys as a resource. We work again throughout the nation and internationally. We hold the Utah Defense Manufacturing Community status, which is one of 7 defense manufacturing communities in the nation. And so for those of you doing aerospace and defense, that's something of interest for us as well. And so today we'll focus on the outdoor products, but we're also well versed in advanced materials, manufacturing, aerospace and defense, and many other industries. And would love to connect with you guys as you go through. To kind of set up why we're talking about the outdoor recreation economy, I just wanted to show you some of the numbers before we jumped right into it. But it accounts for about 1.8% of current GDP for 2020. And that's down a little bit from previous years, obviously due to the pandemic. A lot of the outdoor industry was affected in different ways. Talk a little bit about the segmentation of the outdoor industry, but you probably heard in the news, how RVs and some of the motorized vehicles were at all-time sales, while some of the bike companies and some of the human-powered stuff was either dipping, even in soft goods, dipping due to supply chain issues as much as anything, even though there was unprecedented demand in some of those areas. And so I'll talk a little bit about how it's segmented, but just wanted to kind of show you some of the numbers here. We are a significant industry. However, the outdoor industry is made up of a lot of smaller companies that come together to create a fairly large impact for GDP. And the outdoor industry was recently, in the last 4 or 5 years, brought into the GDP to be included as a number, which was a major win for the industry itself, but also just shows the growth and impact that it really has. And so I just wanted to briefly kind of show you a little bit of the scope of what's going on and a little bit of the pictures, how this is broken down across the nation. So I will talk about kind of the segmented industry. The outdoor industry can be divided into many different ways, 3 of which I talk a lot about is motorized, human-powered, and hook and bullet. The reason I bring these up is because they all kind of serve a different demographic, although a lot of you guys out there probably have or do multiple and cross segments. But the important part about this is just kind of how the industry looks at them. And so just kind of human powered is bike, skiing, and this is a fairly vocal audience, very powerful vocal audience. They consume a number of different products, soft goods and whatnot, but as an individual, the value to state organizations, tax bases, and some of the ways that incentives are given back, this is one of the smaller percentages of the overall outdoor industry. We then kind of come to motorized, which is side-by-sides and just any kind of motorized vehicle, snowmobiles, etc. And this is a really interesting industry because through taxes, they're one of the more valuable recreators that we have because they purchase gas, they often stay in hotels. And so from a measurement perspective, this is an area of interest for many different groups. And with that comes some of the land use discussion of, are we using land sustainably with some of this? And so some of these topics come up within this group, but from an economic standpoint, they're very important. And then the last is the hook and bullet group, which is kind of fishing and hunting. This is a very important group and often one of our best conservation resources. Tax dollars, or excuse me, dollars coming from licenses go into sustainability, trail assistance, and a number of different programs that really keep the outdoors gorgeous and protected. And so that's kind of how a lot of these are divided up, and you'll kind of see that we'll talk about different products, but with that, carbon fiber extends into each and every one of those different segments. And so one of the important things as we talk about, and one of the things I always try to bring when I talk about the outdoor industry, is what the outdoor industry brings to some of the ancillary industries, be it tech or finance or manufacturing, any of these. But outdoor industry has a focus, and I believe each of these companies really should have a sustainable business practices focus. And that's something that we're pretty dialed into, our consumers focus on heavily. And so it's something that the outdoor industry can be looked at for a model for some of these other companies as they look to do the same thing. And as we talk about recycling and supply chain, how do we reduce, reuse in those ways? Another is equitable employment and accessibility. These kind of go hand in hand, but the outdoor industry is working hard to make sure that it's either reforming its image or just making sure that its image is representative of all the people who are using our activities, and then that everybody has accessibility, whether that be to the mountain or the rivers, lakes, trails, whatever it might be, that they're accessible, but also accessibility within the workplace. And again, I just like to bring these things up as I believe it's a great model and something that we can bring into all of our business. Another is health and wellness. The outdoor industry is very popular for its use of health and wellness and work-life balance, where we are able to help companies outside of the outdoor industry bring employees to our locations due to the health and wellness work-life balance that some of this provides. And so you can go into these companies to work with them and really realize that, but working and supporting these companies in your areas can also help support your own employment and kind of corporate responsibility goals. And so I just wanted to talk a little bit about that. Here I show a few of Utah's products made with carbon fiber, so you can kind of see some of the division separation. But here we have Snow-Go, which is really cool. Bike made from carbon fiber. The whole frame is carbon fiber. This is a long rifle from Christensen Arm. It's a hunting rifle, one of the most precision rifles made in the world, made also out of carbon fiber. Kemper, which snowboard, BPS skis, and then Mercury Wheels is another. And so you can kind of see how these different organizations and groups are starting to use this. And with that, I think that I'll hand it over to Matt to do his presentation, and he'll show us the breadth of products that are available and talk a little bit about how different materials are being used for that. So Matt, please.
Thank you, Dustin. Let me share my screen. So here it is. Go back. Can you see it? Is okay?
Yes, I can.
Change to panel. One second. Okay, let's start then. So as I was explaining, I'm mainly working with Epsilon Composite development in Northern America. Large company, some kind of world records. We are dealing with industry, with aerospace, but we have also products for sport, such as sporting goods, or for such as consumer goods. Globally, Epsilon is trying to propose some alternative technology to what is existing. Could be the standard material, metal or wood, but also some kind of advanced composites mixed with different kind of fiber, and it could be fiberglass, but obviously carbon fiber, and recently also many optic fibers for monitoring the parts and so on. So please do not hesitate to have a glance on our website. You will find some very interesting information. Now I will more focus on what is our core competency is the pultrusion, and today is 95% carbon fiber epoxy pultrusion we are dealing with. As I was explaining, we can mix some kind of fiber. We can also use alternative resin out of epoxy, such as also thermoplastic and so on. But let's say that today the large part of the market is still carbon fiber epoxy for us. Why we originally focused on pultrusion? Because of many different advantages. The quality of the composite is high in a way that we need a high volumic fiber content in our product so as to polymerize. So we are talking about 70 to 75% volumic fiber content. We have practically no void in our product. It's less than 0.2%. And we have a consistent quality because it's an autonomous process working continuously 24 hours, 7 days, and it's monitored by an automated system. So this gives very high quality product, and further than that, we have also very sharp fiber alignment, no limit in length, and obviously a low labor cost, meaning that you can install a pultrusion line, whatever the country you want to produce for, because practically the line, once you start, you just check if everything is working properly till finishing the carbon fiber spools. So for those that are not really familiar with the pultrusion, it works like that. So you have a rack of or creel of carbon fiber spools that send the yarn inside the dye you can find here. We can add some kind of mat or special fabrics to reinforce the product, but mainly that's made out of a lot of unidirectional fiber, giving a product with very high tensile, compression, and flexural strength and modulus. So you have all these pools, dry substrate, I would say, that get into the dye. Here is the dye where we inject the epoxy resin. We heat it. There's a lot of pressure inside, and under a very short period, we polymerize the product with the shape you really want to give it. It's a two-dimensional shape, but it gives the shapes designed by the dye. So then you have a pulling system that pull the profile out of the dye, and then a cutting system. If you have large parts, for small rods, for instance, we spool it. We can make up to 15,000 long, 15,000 feet long spools, for instance. That's the base of the pultrusion you're probably familiar with. Then we also propose an alternative technology called pool winding. That's more for making some kind of tubes, for instance. So you have the same basic process, but in between the rack and the dye, you have a pool winding module. So in this sketch, you have two modules, but we can go up to 11 modules so as to structure a very thicker product. And at the end, that's the same process, but the difference is inside your product, out of the dye, you have a really structured element, still mainly out of unidirectional fiber, but then depending on the speed of your reels, you can apply different kind of orientation of your fiber. Generally, you have your reels rotating in a way and an alternative wheel rotating in the other direction so as to compensate and balance the product layer. So then based on this process, then we have ability to make many different products. As you mentioned, Dustin, you have many different segments, and sorry for that, I won't speak about our motorized application today. no fishing devices too, no boat gears. I will present some maybe not so famous application, but here are what we are dealing with also. So as we have ability to make this kind of tube, these are generally quarter-inch tube. From these tubes, we can make arrows, we can make kites, structure, for instance, but also we have been developing structures for a backpack, sorry, working with a company called Mystery Ranch, you probably know. But we also develop very fancy softbox cars for the kind of Red Bull events, but also different fun structure like that out of tube. So the idea is once again to have a very lightweight structure. Then we can manufacture from the pool winding system some kind of telescopic gears. So for instance, there's a company here in California called QuickBlade that have developed some telescopic paddles for stand-up paddles. We make a lot of tripods. So these tripods mainly used for photography and broadcasting, but some of the tripods are also used for hunting, for fishing. So these are the I would say telescopic solution out of a pool winded tube. Then we also propose some stiffeners. So here is a surfboard with two stiffening rods inside. So that's a niche market. But what we have been working a lot on for the last, I would say, 5 years is foil reinforcement, and more than reinforcement is stiffening, because you know that the foil mat, the foil main part here, the vertical part needs to be as stiff as possible to have the best yield of your foil, especially for racing boards. Here in this part, for instance, is made by a San Francisco company called Mike's Lab. You have what we call a carbon fiber laminate, once again out of pultrusion, made out of pitch fiber. So the pitch fiber, if you're not familiar with, it's another family of fibers that is not a polyacrylonitrile fiber. But it's very, very stiff. And for instance, we have ability to make a laminate up to 450 GPa, that is 65 million PSI. So the laminate itself is like 2 times steel stiffness and 5 times lighter. And obviously, if you integrate this kind of laminate in a foil, but in many different environments, you directly increase the stiffness of your product drastically, I would say. So that's a very trendy market right now, just introducing this laminate in a structure. Some interesting stuff also, we have been doing some bikes out of fixed cross-section tubes and so on. So mainly using thermoplastic lugs. You can see this kind of kids bike also. So the idea is using out of the shelf tubes and just assembly them with different technique, but the main one today is it's thermoplastic lead or thermoplastic anchoring system. Other kind of technology we develop is what we call Carbogram. So once again, we introduce some carbon fiber laminate with wood. So originally it was mainly used for a roof system, but recently we have been asked to propose this technology for skis, but also for fancy bikes like that. So that's just an example of what can be done out of once again very high quality laminate made out of a continuous automated process. And that's, I would say, I would have like to share more application and more time, but I would say, especially as you know, French people like to hear them speaking, I would say to limit my time to 10 to 15 minutes.
Thank you so very much. And I think that gives us really an overview of all the possible products that really can be used. Many of you are probably using something similar out there. And so with that, we want to dive a little bit more into an individual company and how they're doing things first. So up first, Carl with NV Composites, if you'd like to begin your share.
All right, let me see if I can share my screen. Let's see here. Where is the share screen? Okay. Let me know if you can see the screen yet.
Not
You all
yet.
see that? Is the
Not yet, no.
all right, let me see here. It says share screen. Multiple participants share simultaneously. I hope I'm
Yep, looks like it's starting. Yep, we got it.
I think you got
okay.
it.
I work, as I said before, my name is Carl Turner. I'm a product design engineer for NV Composites, and primarily we are a manufacturer of bicycle products. However, how we started about 15 years ago is a couple engineers, myself included, had a couple of ideas about how to make some bicycle wheels a little better, more efficient, and of higher quality. And there were a couple of other guys that were tired of paying retail for bicycle parts, and we were put together with them as the investors, and created NV Composites. We didn't start out making bicycle products. We started doing OE manufacturing for, of all things, we did work for Black Diamond, and we developed the Cobra ice axe, which I think the next you'll have more information about that. But once we got more and more people to pay for these OE stuff, we were able to fund our own products and more delve into our own line and have control of that. And then we started offloading our OE products. So currently we are based out of Ogden, Utah. We have about almost double what is on the screen there. We have about 300 employees now at our manufacturing facility at Utah. What kind of like the ideas that we had were that we thought to make wheels better is, at the time people were drilling their spoke holes through the rims, and what we thought we could do to make that better was to actually mold in the spoke holes, because as you know, as you cut fibers, you aren't able to transfer any stresses through them very well. That was kind of our niche, and from that we were able to get some patents in how we are molding our product, and actually come up with a efficient manner to mold those things. Let's see here, next slide. Is it not going? I'm not able to go to the next one. Okay. So what kind of sets us apart with the wheels is none of our rims are painted. They're out of the mold, and what you see is what you get. We have very few flaws in them, and we mold our spokes holes in there. A couple of other things that we developed or started to develop or delve into are the other bicycle products that are on the bicycle, such as stems, handlebars, forks, and we got really good at making some of those things. And currently now we just started making our own bicycle frames that we just launched this year, and we hope to compete against the biggest players in the market, such as Trek or Giant or Specialized. We are currently on a couple of the pro tour teams, the ones that do the Tour de France or the Giro. And what we use those teams for a lot of our kind of like our R&D. They go out and test a lot of our products, give us a lot of feedback. We're able to go back to the drawing board and use their feedback to make our products even better.
Carl, can you hit the little button to your right there to go into presentation mode? It's just down a little bit. It's that box with the, yep.
This guy. Okay, I'm sorry. Terribly sorry.
No worries. Should be able to click from there. Thanks.
So some of our, we've had a lot of buzz in the marketplace, even though we're a relatively new company. We've actually had Eurobike Product of the Year. And we have the capabilities to use we have our own wind tunnel specialist based out of the Mercedes-Benz wind tunnel in England, and we use that facility to iterate and launch or develop our products, which is kind of nice to have the same capabilities that the F1 cars use. Let's see here. The next one is we also have some OE bicycle products, and these are the high-end bicycles that spec our wheels and our product on their bikes. And it's a mark of how far we've come in this short amount of time is to have our products, our wheels, and on the highest of bicycle companies such as Santa Cruz and Cannondale. What also sets us apart is we currently make all of our wheels out of our facility here in Ogden, Utah. And as of yesterday, I think we just launched our 250,000th wheel made in our facility. We're kind of happy and proud about that. That just happened yesterday, ironically. And because we have all of our facility here in Ogden, we're able to control a lot of things that other companies can't, where they're importing either their fibers or their other products. They're stuck in Los Angeles right now, outside of the port there, and we're able to keep and maintain all those things in-house, which really allows us to be flexible and kind of nice. So we just 3 years ago moved into our new facility. We went from 10,000 square feet to 60,000 square feet, so we're able to make a lot more product faster, which is kind of nice. We have our own in-house machine shops, so when we have our ideas, we can go to our own machine shop, make our own tools, and essentially fail fast, which has allowed us to really keep pace or outpace a lot of other companies that are in the same part or same niche as we are. We also have our own in-house testing facility where we can validate and disprove or our own products and go back to the drawing board if we have to, which is really kind of nice. Let's see here. A couple of the other things we make are, this is a bicycle hub. Let's see if I can see that. Can you, do I end my presentation? Let's see here.
Yeah, if you'd like, that'll make you full screen, but we can see that.
Okay. Anyway, so we can make full carbon hubs, where previously, prior to us, they were all made out of aluminum, or they were bonding carbon shells and pieces together, and that makes us kind of unique. We're in-house, we can make bicycle forks or full wheels. this is a disc wheel that we make. Yeah, we're just kind of like really passionate about the bicycle industry and how efficient carbon fiber is. You know, it makes it, you know, quite a bit lighter than the some other materials, and you can tune it to how things feel when you ride. So yeah, that's essentially us. You know, we're relatively new. You probably haven't heard of us, but we're excited, and hopefully soon you will be seeing a lot of our product out on the road. So thanks very much.
Yep, thank you, Carl. And I do have to say, you know, ENVI's a major leader in this space, and a large company, all things considered, and continuing to grow. So you will continue to see them and watch for those innovations. We're very happy to have them here, and appreciate you joining the call.
Yeah,
so
no worries.
The next one, I'll turn over to Stu Gleason with Black Diamond.
All right, I'm working on getting the presentation going.
If you're able to start your video as well.
Yeah, sorry, coming up
No
here.
worries.
All right, hopefully the video's on, and can you see my presentation?
Yes, we can.
Great.
If you want to hit presentation mode as well.
There we go.
Bottom right, little box with the down arrow.
Yeah, that should be, it's showing that I'm in presentation now, is that correct?
You're currently in slide mode. If you go to the bottom right, you see the little box with the down arrow.
Yeah, see here. With the down, this one here. Slideshow.
Far right on at the very bottom of your screen.
It sounds like bottom right. Yeah, sorry, this is not. It's not.
Oh, Carl, will you stop share? Sorry.
Oh, okay. Sorry. There we go. Terribly sorry about that.
There we go. If you want to go ahead. Present. It should be the one to the left. Right
Okay.
there. You got it.
Okay.
Thanks.
All right, great. Is that working now?
We're all set.
Okay, perfect. Well, I'll get rattling here. First, again, thank you so much for having me. This is a pleasure to be a part of this, and it's something to follow after ENVI. As he alluded, the history of our project, the Carbon Ice Act, sure did happen with these guys, and I wasn't a part of that, so I can't speak to it. But you know, the community is small, and I'm sure we've all worked together at some level. Talk real quickly too on Dustin, your comments on working in the outdoor industry. I spent 15 years in composites with aerospace and defense, and it's been quite refreshing coming to the outdoor industry because of the work-life balance and some of the relationships that I've been able to create. So I think this has been a really healthy transition for myself. But one of the things I was nervous about losing was the technical aspect of the gear. And I'll tell you, coming to Black Diamond, I have been pleasantly surprised. All of the equipment I work on is all certified. So effectively it's aerospace equipment, but stuff that you get to go use. So in this case with the Carbon Ice Acts, we'll talk about this in a second, we're still working to standards and testing to standards and validating those. So I find it very interesting. Also, this presentation is about a quick and dirty design synthesis. And ultimately a project that's been shelved at this point. So this is not something that's going to be commercialized anytime soon, and we'll talk about some of the reasons, but this has been really fun where we use the tools at hand to come up with a quick solution. And as Carl said, how do you fail fast? Because I think that's a key to innovation. All right. So why did the project start? Well, it's time for a redesign. The current design's been in the lineup for years. I think, Carl, you'd have to correct me, but I think it was back in 2007 when the Cobra was actually launched.
Yeah, that's when we were doing it.
Okay, yeah, perfect. That makes sense. I think you were probably working with Jason and
Jason Shears and Randy Smith. Yes.
Wonderful. Yeah, no, I know both of the gentlemen there.
And Joe Scriven at your place.
Yeah, Mr. Joe. Yeah, he's still a fixture at Black Diamond and quite a character at that. Anyway, well, what's going on with the Carbon Ice? Well, number one, not a lot of people buy these things. You can imagine that a high-end carbon tool is a very specific piece of equipment, somewhat to the carbon rims. Then we had higher MOQs for the number of sales that we had, and costs were rising. More importantly, the competition was beginning to overtake us. Gravel and Petzl, they have really competitive products out there, and it's important for Black Diamond to stay on the forefront of innovation and putting the, we want the best athletes with the best equipment, and that's core to our business principles. On this slide here, you can see that the beginning, I think it was in '92 when the first, I think this is the X15. I'm actually not an ice climber myself. I don't prefer to be as cold and wet as it takes. But over the years, you can see, I think in '03, you saw a major transition in overall geometry, as well as a leashless design, which is interesting. You can see on the, about halfway over, you have a leash attached to the ice axis. And on the right, you go to a leashless, where it has a little grab on the end of the handle, and ultimately with the carbon tool. But time for a redesign. All right, well, when you go for a redesign, what do? You need the right inputs. And for this project, what are those? It's performance, geometry, weight, feel. The geometry, I'm not going to get into that too much, but you can imagine that as with wheels or any other product, the geometry is always evolving as we learn more about the sport and the different changes in hand positions as the sport evolves. We need to adapt to that. With respect to weight, in this case, of course, overall weight is important. It looks like we're at 1 pound 6 ounces, as you can see lower in the slide. But also, where is the weight? Just like a wheel, it matters quite a bit where you put it, and that ultimately affects the feel of the product. If you were to swing a series of ice axes into ice, you would quickly notice the swing weight, and the damping of the material directly affects the performance of the product. So those are the inputs we're getting from our athletes, from the people who've been a part of the sport forever. A lot of people provide that feedback. We also have certification requirements, and this is one of the things that I actually love. That's can be quite challenging, but I also love about my job is that we have to meet these requirements. One, if we want to sell products in Europe, and also if we want to put certain labels on our product that indicate the quality and performance of it. So here we work with the CEN, which is the Committee of Standardization in Europe, and the UIAA. And so some of the requirements from those specs would be shown in the loading diagrams in the upper right. Here, I think there's I think there's 3 different styles of loading that ultimately are shown here. You can imagine you see a bunch of different tests, but these are the standardized tests that we need to meet as a baseline. We always like to add more than that for a high performing product. Of course, the cost is a big deal. Right now, this is a $430 at retail. And to be honest, it's probably going to go up, and you can't even buy them. We're out of stock. So if that tells you anything about our supply chain right now. Also, I thought it was funny or interesting. I went through the instructions last night of the ice tool, and a lot of the warnings help indicate what this goes through as well. You can see the ice tool has been used to remove snow from your crampons. So you're slamming this against a metal tool, and perhaps you have quite a bit of adrenaline, or you're maybe a little scared, and so you're hitting it probably pretty hard. The upper right instruction image shows where you would be leveraging the tool over rock, which is really quite common. If anyone has the pleasure to watch The Alpinist, currently streaming on Netflix, you'll get a very good feel for how serious these tools really are used. It is not just a simple going up a nice waterfall anymore. Moving the tool out of plane based just on the pick, or using the tool itself to slam in a piton or an ice tool. Those are things that are really quite common, and you need to be careful while you're doing this. I put the little the danger sign here. We had the danger or death indication at 7 different locations within the instructions to warn you about how to use this tool. So again, it kind of builds or sets the stage on the end user and what we need to be aware of. All right. Again, I can't iterate this enough. This was a really quick and dirty effort. For those of you, I noticed there's some who have probably far greater experience in FEA and analysis than I ever will have. Will appreciate the simplicity of this, but I think this works. One of the things our team does really great is, I think this went just a couple of months, we had prototypes and tested and understood where we were and could make a go, no go call. So I'm really quite proud of that. But how do we establish the baseline? We identified our stresses using an aluminum tool in FEA and loading it with the static certification tests. So we wanted to find out what the stresses look like, our first swing at that. From there, we are going to create a laminate that can handle these stresses using classical lamination theory, in particular the laminator software. And then, the whole time we were going to base this off standard modulus fibers and common epoxy properties. We had no, ultimately our supply chain goes to an Asian-based supply chain, and so we had to be prepared for the unknown of materials that would be available.
Hey, Stuart.
Yes, please.
I apologize. I've been trying to let you stay in this mode, but if we escape, you're in slideshow mode and not presenter mode. And I think some of these slides are well worth having be larger.
Oh, no problem. Okay, how can maybe you could talk me through how to.
The one to the right. Yep, that one. Hit that.
Is that better?
Oh, it's because you're.
No problem. Let's see.
You're hitting the right one. It's just that you have a little bit different setting there. So
Okay.
Your next slide. It's okay. I apologize. I don't want to interrupt your flow.
No worries. And yeah, and I apologize. Sorry, this is last minute. If you can chime in, I'm more than happy to quickly try to make. Let's see. What about this fit slide to current window? See if this does it. No, it doesn't change. Okay. All right. I'll go back to where I was.
Yeah. You could just go to the I think preview mode instead of the presenting mode. That'll at least keep it, I think, full. I think there's a preview mode or the reading view. There we go. Reading view. That'll at least, I think, keep it in. Yeah. So that's still better than the other one.
Okay, great. Hey, thank you so much. I appreciate the feedback there. And again, go ahead and stop me at any point. I'm trying to watch our time. What's my cutoff, by the way?
You got about 5 minutes or so.
Okay. That's all right. Cool. We'll keep rolling. Okay, so we talked about the different initial loading approaches for us to get a baseline on what stresses were going to be present in the structure. What was really interesting is that, in the end, we found that the tension and compression stresses from the different, there was the lateral loading is which ended up driving the design, and we had about 500 megapascal of stress in the FEA. The shear was really quite high, and we've never really been able to resolve that. We built parts and they ended up passing, and I'll show that in a second, but the shear stresses in the FEA analysis were much higher than what the laminator would tell us we could ever meet, and but there was some kind of disconnect there because it ended up working. So for the first laminate, a bunch of zeros, plus minus 45s to help try to mitigate the shear stresses there, and we moved on to building a part. All right, construction of the prototype. Man, we worked with a local partner. I can't speak more highly of the community in the composites world. I have a lot of friends from working in the industry who are all really eager to help. We all got to learn a little bit and work together. Took about 3 to 4 weeks to get our first part. We have a bit of a wizard for internal R&D machinist. I've, to be honest, never seen anything like what this guy can do. He, not that the tool exhibits that, but some of the other things he's created, but the tool came out in less than a week. Worked with dipped silicone bladders over a Teflon mandrel, and you can see some of the fixtures here on how we handled the bladder molding process, as well as all CNC ply cut plies to keep it standard. Some of the things that were important. Why did I choose this direction? One, I wanted to make sure that I could stagger my overlaps, maintain as much continuous fiber, consistent sidewalls, etc. So this was our first approach. Unfortunately, the first part came out beautiful. That's the worst thing. As a composites engineer, I like that, but others might have begun to think that this was a little bit easier, and subsequent parts didn't come out quite as nice. So we did learn our lesson. But first prototype part came out looking really quite sweet. See if I have any other comments here. It was a 250-degree cure, Newport 301, I think, because I had some free material available, and we put the mold in a press to cure it. Let's see, double checking. Okay, that's I have there. All right, testing static loads. Well, go figure. It's failed at the fitting interface. Not a big surprise. We didn't model those stresses at all. We chose to fix constraint. But again, the team I work with, I just love it. Really, the question was, what's the quickest thing we can do to force the next failure mode? And so we put a bunch of hose clamps on. We glued them on. We tightened them down. We glued them on. Glue probably didn't really do anything, but then we were able to pass the loading test with the same part that we had. We realized what the equivalent additional strength the hose clamps provided were, added some UNI, and we met the requirement. So within really quick iteration, we were able to meet the static requirements of this part. Again, that's nowhere near where it needs to be, but it was a first step for us to establish our baseline. All right, damage tolerance. Boy, we failed really, really quickly here. The curb test, I'm sure Envy has something very similar to this. There's maybe a more cyclical version, but if you take a carbon part to a concrete curb, you will have an immediate feel if that part is going to be anywhere close to what it needs to be. This one was not. We knew it wouldn't, but we wanted to see what would happen. Within a couple of swings, it got soft and fell apart. Let's see here. Let's double check my notes. Yeah, and again, we were trying to fail fast. At this point, where are we at? We identified baseline, created a laminate, built some parts, built the static tests, and failed on the damage tolerance. Well, we needed to create a path forward. That path forward looked at an advanced composite structure as well as our manufacturing partner. I'm going to start rolling through this a little bit quicker because I know I'm going to start running short of time. But what are the things that we could have done differently to improve toughness? Change fiber orientation, reorder the laminate for thermal and translation of stresses throughout the laminate as it's loaded, make it more manufacturable. Different manufacturing process altogether. Maybe RTM would have been the way, maybe make two shells, maybe a couple different ways. Most likely a thermoplastic toughened resin system would be appropriate. I know I showed the Konica MX136 slide on the lower right. I had some experience with that before. I don't think that's appropriate for a cold temperature part, although we haven't tested that to see how it really did perform. Different fiber reinforcements, some aramids, different material formats, braid, etc. Localized buildups or ply drops. Again, we came up with an effective modulus and ran with it with a constant cross section, just again for this first iteration. Different resins, fiber volumes, excuse my spelling error there, different manufacturing partners. I'm sorry, these notes actually I probably should have put in the next slide, but again, in the sake of time, I'm going to move forward here. I think this has been really interesting working with the Asian supply chain. Not only has it created a lot of challenges, but I'll be honest, it's one of the highlights of my career. I find so much enjoyment in working over there and understanding the differences. Especially since I grew up in such a US-based system and thinking we had it all figured out. And man, I think we still have some challenges. And it's been very impressive as I had a chance to travel the globe. What have I learned? Relationships and correct inputs matter. Relationships are everything. Visits to Asia, especially now, are rare, maybe quarterly. That's not enough to stay on top of a project. And because of that, relationships are critical. When I hop on the Zoom, I need to make sure that we have a friendship and they understand where I'm coming from so they can predict how I'll be handling our project. Matching capability, both technically and a scale of operation, is even more critical as we move overseas. The facilities also, they need to have relationships with the proper component and material vendors. I was blown away, as I'll talk a second here at in-house about pre-preg. You can't just buy Newport products or Tenkati products over there. I mean, you can, but not really in the world that I'm operating in. And I'll talk about that a little bit more in a second. The correct inputs, boy, this defines everything. How do you properly communicate that? I can say that I need a part that meets this test requirement, and there's a very good chance that they will provide a part that does that. However, at the detriment to what other feature? This is where working closely with the teams, creating those relationships will keep the visibility on the project correct and provide an opportunity for success. And I could talk about that one forever. In-house pre-preg. growing up in the composite industry, I thought this was the most interesting. I'm used to an off-the-shelf product that can be sampled, that can be bought, and is consistent, tested, comes with a certification. Not the case with my experience. Each company has their own prepreg line or works closely with a partner. They all have their own secret sauce, and that comes to the actual materials that are put in, as well as the methods in which they process it. And everyone on this call knows it's all in the process. And that's most likely proprietary or very challenging to get the right information. Allowables don't exist. You need to test this season's batch. You need to test next season's batch. You need to keep working with them to make sure you understand what's going into the product. And again, the relationships drive the process and understanding and future development. One of the challenges here, because I know, again, I'm a firm believer in domestic manufacturing. However, at the end of the day, it was $100 per part with our local partner here, best case scenario, just for the carbon shaft, where I'm already getting samples for $20 a piece out of Asia or out of China here. And that's really hard to compete with, especially when the end retail price is such a critical part of the product. In the end, this project was canceled. Why? And again, I know we're really short on time here, but it competed for resources on similar projects already in the pipeline. Black Diamond, imagine NV similar, works on a 2 to 3 year project timescale. I started stuff a long time ago that's coming to fruition. Because the technical solution wasn't immediately available, we had to take a hard look at it, and maybe it didn't fit in with the resources we had. Yeah, again, it looks like we're really short on time. But again, I want to say a big thanks to everyone here. Again, Carl Haas, Adam Gans, hopefully Adam, you're on here. He was really instrumental. He's a super helpful consultant in the world of sporting goods, as well as understanding Asian manufacturing. Brian Lundy, one of my first mentors, Eric Ruby, Jack Stites from Phil Lauer, the B&D R&D crew, who I am very proud to work with and also call close friends. So with that, I'd like to say thanks, and I'll hand this over to you, Dustin. Thank you.
Fantastic. Thank you, Stu. You want to stop your screen. So we have about 3 minutes, and I have a question, but usually better to turn it over to the group. If there's anybody on who has a question to the team, we'd love to answer it. If nobody has a question, I have a question for Stu and Carl. Feel free to chime in, Matt, as you know, but I was having a conversation yesterday about, we do have a question. What kind of production volume for ice axes? It's a quick question.
Yeah, that might be a tough one. I don't know exactly, but I would guess it's 1,000 pieces annually. I'd have to be careful there. I don't know our total distribution stream. I got to be on the design side of that, but it's pretty low. There's only so many people coughing up the cash for these.
And that's pretty common within the outdoor industry. We are small but mighty once combined. So the question that I wanted to quickly ask, we have a couple minutes here, is just about extruded aluminum. Are any of you guys working with that, or anything else that might be up and coming that is kind of interesting for this society to be aware of or be thinking about? What's next, even within maybe titanium?
Maybe I'll say something really quick. One of the gentleman, Brian Lundy, I worked with, I was showing him the process, and he immediately said, hydroformed titanium is your solution. He didn't think the composite was the right application here. So I don't have any direct experience with that. I think it's interesting. I'd love to learn more, but I think that probably he's normally pretty spot on with these things. So I bet that's an avenue that'd be worth looking at.
Carl, have you looked into that, or Matt?
We currently have some extruded aluminum products that we partnered with our sister company Mavic out of France. So we have a line of hubs that are at a lower price point because aluminum is isotropic. The properties are the same in every direction, and it's predictable and easy to machine. And so we use that on a lot of our price point wheel sets. So we continually look at that. A lot of the, we have steel spokes, and we've looked at titanium as well. So we kind of mix and match depending on the application in the field that the consumer we think that they desire.
I would add something. Obviously, we compete all the time against aluminium. I see only advantages by using carbon fiber, obviously, except probably the price. For pikes, Stuart, I would say that the advantage is, once again, here is the product, the carbon fiber is not cold. And when you are in a cold weather, and if for any reason you have to get something out of aluminium, it can be stuck on it because of the cold and the ice, what will not happen with the carbon fiber. But I would say, as commented, all material have their own properties, and for aluminium, obviously, it's a lightweight one. It's much cheaper than carbon fiber, and we make, especially when we have to build structure, I would say hybrid pots with metal ends, for instance. Obviously, we have to take care a lot about galvanic corrosion between carbon fiber and aluminium. So my dream is one day we will use everywhere carbon fiber and not anymore aluminium, but it's not the case yet. and obviously some persons specialized in aluminium will probably find some advantages I'm not thinking about right now. But the price, I would say, carbon fiber is lighter, is higher strength, is stiffer, is not cold. So only advantages from my point of view.
Yeah, I think that's more votes for carbon fiber, and we're talking to the right group in that respect. I think we're at time, and so I'll hand it back to you, Ryan Paul. Thank you.
Yeah, thanks, Dustin. I do have a question for the panelists. Since one of the themes that we have for today is on recycling, just wanted your guys' thoughts on end of life and recycling for some of the more leisure and sporting and outdoor focused areas for the different products.
So if I can just, the product, the carbon fiber is inert. I think it's inert is the term. So you can let your bike 100 years there will be no contamination. That's the first point. That's important. You can't contaminate the environment. Then obviously many people are speaking about thermoplastic to recycle the product, and that's obviously a very interesting topic right now. Many people are working on. I would say that today for thermoset resin, just one second, thermoset resin, companies are now burning the resin and get the short fiber to make new panels, for instance, out of a short piece of fiber. There are also some project with small fiberglass where you transform it in concrete and things like that. So yeah, there are many work on that, but I would say that that's a product that does not affect the environment, but obviously it's better if you can reintroduce it in a production loop after its life.
For us, we send our product out, and we don't usually get a lot of it back. It stays out there for years and years. What we try to do about recycling is a lot of times when we're making complex shape material or products, there's a lot of little waste that is introduced. So there's like product from your cutting table or your whatever process you're using, there's just materials that don't get put into your product, and we're trying to look at ways to not repurpose, but move that product into making something that's maybe not necessarily structural on our bicycle product. So where we can take the shorter fibers or the mismatched angles and put them into something that would otherwise would be put into the landfill. So we're very cognizant about that. That's kind of what our industry being in the outdoor industry kind of demands that you look at ways to mitigate putting things in the landfills.
Yeah, and just to build on both of those, and I think a general comment, I feel like the outdoor industry really takes pride and ownership of these topics. Everything from, socially, we've seen all the change, and we've been dramatic that we have to implement those changes into our company, but specific on sustainability, we write this into the briefs now. We take a hard look at it. Not only do our customers demand it, but our distribution channels demand it. A lot of the larger places, the larger opportunities for us to sell our product, they require some level of effort into this world. So not only is it important to BD, our customers demand it, our distribution channel demands it, and we're going to see that everywhere from properly sourced materials to everything that Paul and Matt have said here, in which you need to pay attention to the drops, the scraps in the material. I know that, and for instance, on the transceiver, we work to nest some of our adhesives, or some of the film, the VHB tape. We're nesting as many pieces in there so that we can eliminate scrap. So I think it has to be a holistic approach. And I think the outdoor industry is an excellent place to start driving that change.
And if I can just add and maybe put out a pitch there, UAMMI is actively working on how to recycle for our industry. We are actively working with ski and snowboard companies, snow bike companies, and other outdoor companies. One of the things that we are looking for are locations for people who can do this to repurpose it into a product that might not be structural, as was mentioned. The other is, again, we kind of have low volume. And so how can we collect it in an efficient way and send it off where there's enough volume that it is usable for different groups? And so I've put my contact in there. If you guys are involved with this in any way, UAMMI is actively seeking this, and we have some attention from specific groups that are very important and engaged, and we would love to solve this and do a better job as much as possible. So please reach out to it's info@uammi.org, and that's UAMMI.org.
Yeah, absolutely. Yeah. Thanks for sharing your info, Dustin. Looks like we have a question that came in newly about this. Have you considered product development methods and innovation that allows for easier separation of materials at the disposal end of the life cycle? And so I think that's just for the general panel, if anyone wants to bite at that and give their thoughts.
Our target in our product is indeed to have the major adherence between the resin and the carbon fiber. So sorry for that. What we are targeting right now is trying indeed to have no way to have the fiber getting out of the resin. That's our target today. But as I was explaining, yeah, we are working with universities and different research about today for thermoset. We don't see any alternative except burning the resin and getting the remaining fiber then. And obviously, if you use thermoplastic, many works, and I'm not specialized in that, help to get the resin out and recuperate probably a higher quality fiber than the one you get once you burn the thermoset resin. But no real work on that right now. The work is really to have the product stay and not having interlaminate sheet strength and a higher interlaminate strength and things like that. Not really try to find something that is reversible, and I'm not working on that right now from my side.
I can speak to on behalf of a couple of the snowboard companies here that are, whether it is working on the separation or using different resins that in themselves are biodegradable or more sustainable in that. And so I do know that they're actively looking at potentially even changing chemical makeup or using just a different product altogether that can be is more recyclable. That said, other ways of separating, like a top sheet from the base layers and the resin in between are also in the works. It's about maintaining the integrity of the product because of some of the needs with the bend. Not all these products need to be really hard and stiff, and in fact, they actually need to have some give. And so with those come different complexities, but it does allow for some separation of the layers. So it's kind of different by product, who can and can't really get away with it.
Mhm. Great, yeah, thanks. Anyone else want to comment on that, Stu or anyone?
Yeah, you know, maybe a quick comment. It's funny, we spend so much time trying to make our equipment the most durable, high quality equipment out there. And a lot of times that means that materials have to be multifunctional. And when that happens, it's hard to separate the two different structures to some degree. Now, with that said, there's actually been some really interesting conversations. You can imagine maybe a helmet or some backpacks. There's some areas where you could clearly separate components. But for the most part, we try to make sure our equipment lasts as long as possible. I know, Carl, you're probably going to have a similar comment there. The longer it lasts, the longer the life cycle of the product. And that up until recent years, that's really been the emphasis.
Yeah, for us, it's just we hopefully make products that you won't have to put in a landfill. A bicycle should last your entire lifetime if you treat it right. So if we can make products in that with that mindset, you know, I think that's better for the whole earth and in a whole.
Yeah. Great, thank you. Well, thanks again for the awesome discussion, and thanks, Dustin, for coordinating a great group of speakers, and thank you, speakers, for your time and for giving us insight into what you do. This is a fresh look into some of the really interesting and I've never needed a ice pick before in my life, and I never thought I would have never thought that much went into it. So that was really interesting for me personally. I did grow up in Ohio where it does get cold, but no, we never were scaling anything. I guess it's too flat there.
Well, it's a cold and wet sport. It's a hard one to, but those who are into it are diehard. So I'm sure I could introduce you to somebody. Yeah, absolutely. Okay, well, thanks again. We'll give you the virtual round of applause for the wonderful panel discussion. Thank you. Thank you.
You guys.
Thank
you.
Well, the time has gone by really fast for this 2-day workshop, and so we're coming to a close. Really appreciate everyone who was able to participate these last couple days. Wei Ming, any comments that you wanted to make? I certainly wanted to thank everyone who has worked hard for this participation. Again, Dave from University of Kentucky, thank you so much for all of your help with coordinating things. Your hard work is much appreciated in helping to have this a successful, you know, although the meetings and workshops are often virtual these days, that doesn't mean it doesn't take a lot of work. and so we appreciate everyone's time. So Dave, thank you very much. Wei Ming, thank you very much. And other people at the University of Kentucky who really helped to make this a success. Wei Ming, any comments that you would like to make, or Dave?
Yeah, I also would like to thank you all for the participation for those 2 days, and especially thank you for all the invited speakers. So look at those 2 days. We cover the carbon fiber reinforced plastic composite application from aerospace, automotive industry, energy storage, to for example. And also we cover the marketing side and also cover the composite recycling. So as a composite family, I would say our common target is really to make the composite, I would say, lighter, stronger, cheaper, and also less the carbon footprint. I hope we all had some good discussion. Some of you may have some follow-up potential collaboration. But enjoy the meeting. So thanks.